the data mining classification training on assignment 6. This assignment 6, this project targets, the goal of this project is to use is to create, let me see, is to create um, two predictive model in the form of automated classifier, where I'm going to use a logistic regression, and support vector machine. So before I come down to the assignment on the Word document, let me explain what I've done so far in the code side. From the code side, the requirement is to load all the necessary software packages. And as we can see here, I have Python and NumPy, Pandas, Matplotlib, lib, and these packages are going to help me to create the necessary bind when I'm trying to run this code. So as you see, all these are on the front from line 1 to line 33 is going to, they are just a binary and the parameters that I need from my code to run, and the libraries and the packages that I need for my code to run. And from there, now that the data set that I loaded is wine quality, red wine quality, and it's in the CSV file format. So, and that file, I have it here, which is the data I loaded, and this is the one I'm working on. Going back to the code, I define the plots, and this plot I'm going to be added. I'm going to add those plots to my screenshots in the documentation. And after the plots, now I have to define the reprocessing and engineer. I define the reprocessing by making sure that the missing value is the output is happening before the amputation. And this is where we have the sum function to be called to implement, like to look for that missing value after imputation also. So, and I have 10 attributes to work on. Those attributes it's like they are like columns on that data set that I just showed, where I'm going to be looking at alcohol underscore X and sulfur, and then I'm going to be looking at the total acidity from that wine, fixed acidity from a volatile acidity, and citric acid. So those are the things I'm going to base on. I'm going to focus on my development. So after that, I define here the select function, the select feature, which is going to select when the code run the output from those columns. And as you can see from here, I point out to all future to get the select scores, and have a train logic regression function to run, and I have also the support sector support. Let me see, support vector machine also, which is a SVM, and after that the support version vector, and I have also, yeah, this is it, the support vector machine, which is a part of the machine learning defined right here. So coming down now, that's where the whole function, my whole assignment is based. So from there, now I'm going to be focusing on necessary score and the output that can come out from this by evaluating the model that I'm using, the model which is going to give me the confusion matrix, accuracy score, precision score, recall score, and so on. So that's where the whole project is. And as you can see, this is going to be the result for to create all the plots that are related to the logistic regression that I'm using to create a predictive form and support vector machine that I'm using. So I'll be seeing, we are going to see those plots as here, as you can see, this plot, you can see logistic regression, support vector machine, which is a confusion matrix. As you can see, the learning curve and also ROC curve here. I'm going to add these plots to my screen, and another one, the model performance. As you can see here in this screen, is only the logistic regression is in the blue, and support vector machine is in the orange. So coming down to another idea, you can see here, this is where I combine the combination of all result from the column that I show, which is the 10 or the 12 attributes that I'm using. As you can see from the screen, we have a fixed volatility, fixed acidity, volatile acidity. As I mentioned in my code, this is where the comparison is happening, and we have the wine quality score distribution, as we can see from the screen. And one thing we should also take into consideration is the coming down to these screens here, where I'm saying that the future importance plots. This is where we have the select K best, and also try to show the quality of the red wine according to the data I loaded to my function. So from there we can jump in. We can jump in the code execution to see how the code reacts, and the code is executed to see the output, and then I will be able to add the screenshot of the output to the results. Even though in my assignment I put down all the code, the necessary code to reveal the nature of my work. As you can see, I'm still going to add the screenshot of the execution part of each one, and as you will see the result, the output highlighted, or highlighted in green at each level of where the code is well executed. I'm going to highlight those outputs in green, but beside that, I'm still going to add a screenshot to testify the execution of the code. So let me just go around and go ahead and run the code. Now let me open the terminals. I'm going to open a new terminals. The terminal is going to open. No, I don't need this. Yes, the terminal is open. It's just open. So let me look at that directory and enter it. So that this is the data mining. As you can see from here, yes, let me see into it. Now, let me list the content of that directory. So this is the content of it, and this is the code. The code. This code is going to be attached to, as I explained, is going to be attached to the documents that I'm going to submit. So now let me execute this code to see the output, and let's say Python 3, and the file name Python 3, and the file name. The file is wine quality classification.py. So now let it. It's gonna take a little while because it's a heavy data. It's gonna take a little while to execute. So let me just pause the video. Once it's executed, I can resume back.